Our type of polar equation was the cardioid, which is the heart or butt-shaped equation. So they're all shaped like a heart, and they're a form of the limit zone equation, which was the spiral instead of a spiral. The only difference is that the cardioid meets at a point, which is also the cusp, where it meets at a point and then comes out into two curves from there. And another way to explain this is that it's an inverse of a parabola. So to look at how this works, the cardioid is, there's a fixed circle in the middle and with a point where it starts, which is the cusp, and then the other circle moves around it, and the point on the end of the radii revolves around the circle in contact. So it makes a heart shape similar to that. The equations for cardioid are r equals a plus a times cosine times t, or r equals a plus a times sine times t. You might notice that unlike limit zone equations, where there is one a and one b value, where it's r equals a plus b, there are two a values in cardioid equations. This is what gives it the cusp and the point where it meets on the center of the graph at the 0, 0. So I have two kinds of equations that were graphed on a regular Cartesian graph, and we'll begin with the sine wave. So I just simply graphed 1 plus sine of x, and then I have the table of values over there, and it's in radians, it's not in degrees. And I have another example. The cosine graph, similar, it's 1 plus cosine of x, and then I have the points off to the side. So it's a regular sinusoidal wave like you would expect it to be. And then when you switch over to polar, you get the graphs that we were talking about, the cardioid graphs. So it's still in radians, and the background is rectangular, but it was graphed on a polar. So these two are sine, which you would expect. They're vertical, just like sine when you use it as a vertical component of vectors or of anything that you're talking about. Sine is the vertical. So you have the positive one at the top here. It meets at the point 0, 0 no matter what. If it's sine or cosine, it's always going to meet there. So then you have, this is the cusp area, and it goes down to -1 and it goes down to +1, and it intersects at 2 and -2, because these equations are r equals 2 plus 2 sine. So you're always going to meet at 2 and -2, and you're going to meet the y-axis again at 2 times that value, except for where a is negative, it's going to be -4 because it's 2 times -2. So you end up with -4 where it intersects. The cosine, which is actually on a polar grid, is almost identical to sine, except that it's now horizontal, not vertical. So the cosine, it still meets at 0, 0 in the center of the cusp right here. The positive one goes to the right, as you would expect, and the negative cosine goes to the left. They intersect the y-axis at 0, 1 and 0, -1, which makes sense because these equations, the a value is 1 and -1, or 1 and +1. If it was 2 and +2, you would expect the cusp to intersect up here and down there. You can see that it still intersects the x-axis at 2 times the a value, so it's +2 over here and -2 over there. So it's very similar to the limit zone equation, because if you'd had that instead of meeting at a point, it would have just been circular, and there would have been another circle inside of this graph. So what you have to take away if you want to be able to graph it given the equation, or get the equation given the graph. So we sort of broke it down into the sine equation and the cosine equation. For the sine, the a value is the most important. Both positive and negative, it's where the graph intersects the x-axis. So it's going to intersect at the positive version of a and the negative version of a, no matter whether you have a positive a or a negative a. So then if you do have a negative a sine of t, that flips the graph over the x-axis, as you saw, but it looks identical still to the positive a. And then the graph will also intersect the y-axis when it's sine at 0, 0, and 2 times the a value. For cosine, the a value when it's both positive and negative is where the graph intersects the y-axis, which we saw. And when it's negative a cosine of t, it flips the graph over the y-axis. So it'll still intersect the x-axis at 0 and 2a. Really all you have to make sure is that you recognize if it's sine, which means it's going to be a vertical looking graph, or if it's cosine where it's going to be horizontal and it's going to go across the x-axis. So the key points on this graph is you can know that it's always going to intersect at 0, 0, so that's always a starting point where the cusp is going to come to a point. And then you have to look where that cusp intersects the y-axis for cosine or the x-axis for sine, because that's after you get those 2 points you are almost done graphing. And then the second intersection point of the looping arc after the cusp on the y-axis is for sine is 2 times the a value, whereas on the x-axis for cosine it's 2 times the a value still. So as long as you can remember those 3 things, it intersects at 0, 0, the cusp intersects its respective y or x-axis, what the a value is, and then it'll intersect again opposite the point at 0, 0, 2 times the a value. Those 3 things will pretty much allow you to graph any cardioid equation.